Hello everyone. Here's the my first video about learning system engineering, and my idea was to make a tutorial by learning system engineering by myself. So I think learning by doing is the probably the best um, learning way. So I wanted to expand my knowledge in system engineering, requirements management, and using different tools. In my case, it would be probably IBM products, but it's not limited to. And another idea was to see how generative AI can help working in these disciplines and using the tools. I don't know, just using the generative AI for the development work. I wanted to share the knowledge to others because anyway, I want to learn. Maybe I will just stream this video and maybe someone will find something interesting here. So I'm gonna use for now Coda, just making notes. ChatGPT, obviously. Coda also has the AI, but I want to stick to ChatGPT. I will use IBM Engineering Lifecycle Management that is called also Jazz Suite. So it has a web page, jazz.net, and maybe I will use the Figma for graphical representation. I don't know the um, tool from IBM, so maybe I will switch later to IBM tool. We'll see. So as a first project, I decided to use speed limit warning function in vehicles. If you a driver, especially in Europe, um, in all new vehicles, there is some kind of warning system um, or functionality that either beeping or showing you a dashboard some information. So we will go through it and why I choose this because it's always annoying, but it's important to have. It's helpful to understand how you drive and why it's there in the vehicles. It's not only because it's helpful, but because there is a European regulation. I have a link here that um, do prescribe that the vehicles with some categories. I don't want to jump in which one, but it's usually the normal cars should have intelligent speed assistance system. So I'll copy this text and we will put the function, but also we will rename it to the uh, intelligence intelligent speed assistant system, I say. Yeah, I will jump to the regulation later. There are some um, legal elements in terms of implementation. There are four types of possible implementation, but I want to start with the basic approach. I, I learned personally, I learned system engineering in different sources. One was, of course, YouTube, and I found a very nice video from Math Lab. Um, I will post this in the comments, and another was Coursera and the work experience and so on. So I will try come from basic part and then move to more detailed and of course checking the regulation. So you will be able to see how and maybe why development in automotive is slower. Maybe it's the wrong phrase, but I just want to think loudly. It's my hobby right now to make this function, to learn the system engineering, maybe to see why I'm doing it wrongly. Maybe someone in the comments will help to identify why I'm doing this wrongly. So again, the idea is to learn through some failures, and it's interesting topic for me as well because I'm having I have the mechanical engineering background, and since several years I'm working with electronic systems, and now I want to try myself what can I do. So I will probably do another page here. Maybe it makes sense to use the requirements management tool, but still I will start here identifying a user story. So I think I will do this as a sub page. Let's do the icon. Yeah. And I want to use the ChatGPT right now. So I prepare the test, the request, the prompt, and I found interesting by using generative AI, asking the chatbot to improve the prompt that certain questions will be asked to clarify the request. And let's try it like this. So we have certain proposals, certain acceptance criteria, which is great. And I think it's already proposing certain implementation. And I will answer here what type of warning is preferred. I will answer visual and audio. Why? Because in the vehicle I'm driving, it's implemented like this. And a hint about the regulation, we have the haptic feedback, we have a speed control system on the engine management, we have cascaded acoustic warning. Cascaded means like first it's optical warning, and second is the acoustic warning. It's how it's implemented in the vehicle, so it also says after some time it will be timed out. And the fourth implementation will be vibration on the acceleration pedal, which also makes sense if you keep the pedal, especially in electric vehicles, if you're using one pedal drive. Yeah, so I will choose right now the visual and audio. The second question, should the system use live GPS map data to get dynamic speed limits? Let's say yes. We'll discuss this later. I have some ideas on GPS data, map data. It's also mentioned in the regulation. The third question is the warning intended for all drivers or specific users. All drivers. And we have, should the system allow users to customize the alert threshold? Yes, but we will see what is possible in the regulation. Is the goal to simply alert the driver or also log speeding event for later review? No, no. Because we're developing this, let's say in general, logging speeding event is not the worst idea. So maybe in certain applications will be implemented, like maybe logistics, where the more more attention to the driver style is applicable. And yeah, but for now we say no. We'll see what the answer will be. In the meantime, I probably copy this text to cars and define when I'm going over the local speed limit so that I can correct my speed immediately and avoid fine or accidents. System must detect current speed, must compare the current speed with local legal, which is great actually, great information. So I'll put it right now here, just the text, and we see what the collaboration user story version 2. Okay, it's clarified. Let's copy this instead of this one. Okay, let's read what they have. The system determines the legal speed limit using GPS and up-to-date map data. The system compares the current speed with the legal limit. Driver can configure the custom alert threshold. When the car exceeds the threshold, warning is issued via dashboard display in audible tone. The alert stops once the vehicle speed is within allowed limit. The system supports all driver types. I think this is actually unnecessary because the driver, independently of the type, should be notified. Here, there are certain implementations already, but I want to start more abstract because, of course, we can use the regulation. There are a lot of detailed description there. But I just want to think loudly. So now let's use the doors for starting the writing down the requirements. So right now we have a rough user story, which is great, but let's say this is more or less our requirements. And let's write them down. We will start, we will do the kind of breakdown of the requirements. So I created a trial account in IBM JustNet. It's a sandbox, so it's visible for me. I don't know, maybe if someone wants to participate, I will be happy to share this project. And if I'm coming to requirements management doors next, I have this project. If I first coming this here, I have a dashboard, but what I want to do is to go to artifacts where we have requirements. I switch to modules to put all the artifacts into one module that is manageable. And I want to create a module. I will call it Intelligence Speed Assistant System. Intelligence Speed Assistant System. And I'll put here ISA module, no template. When you're creating a module in Doors Next, you can change this. If your administrator has templates, you can use it. You can choose where to store the module. I will put this in a top folder and the name. So let's try what's going to happen. Yeah, so we have created a module. Module is a set of the artifacts. And now we can create the requirements. Let's just type what we have. It's starting us to have heading, but I will other artifact and I will put here system requirement or a user requirement. What we have here, scenarios, the different types of the artifacts. I will start with system requirement. And what is good by this system, and I think by any requirements management system, it will immediately create ID. So according to requirements management, every requirement should be have own ID. So long story short, I want to maybe first copy user story just to have it. I'll put like this, just as a text. This will be more like information than requirement. Okay, just when you click somewhere else, it creates the requirement. All right, we have our first requirement. I will add here certain attributes. I will add here the artifact type and what else? I don't know. Let's put right now the artifact type and we have a system requirement. So I have right now the settings that I can change all the requirements in different situations. Could be like you cannot change requirements easily. You need to create a change set and you will be able to change that. It avoids unintended changes. So, but now let's continue adding here. I'll do copy paste right now with the Control Enter on Windows. You can create another artifact, and I will do this. Try to do this quickly. Or maybe it's not efficient, so don't judge me how I do this. Maybe there's another better way. I could start with an Excel, and then maybe import this into doors, but I'm doing this very non-efficient if you're working with many requirements. So please, again, don't judge me. All right, so if you hit the Control Enter, the doors creates a next artifact with the same type. So if you want to create another artifact, for example, I want to put, before this requirement, I want to put a heading. So I put here, like I click this document button and I put insert new artifact before, and I will write user story. Right, I'll click somewhere else, and here I go and put this as a heading. So a heading row, and now it's a heading. So what I can do right now is to put another heading before, and let's say functions. I don't know, just to put another heading to have kind of a structure in this um, module or specification. So right now we started the project. We started to write down a spec book just to have a more order. I can put this requirement under the user store. I put demode, and then it's and I'll do the same. So sometimes, okay. So if you want to choose several artifacts here, you choose the first one with holding the shift. You choose the last one you want to choose, and all between is a check mark, and then you put demode, and it's bring the kind of an order. So basically it should collapse right now. If not, you can refresh the artifacts. So doors kind of slower system, but have more structure, and now you can collapse, which is more structured. So maybe I'll consider this as draft requirements. Maybe I'll add another thing, which is called status. Let's see what we have here. Status. I think I don't need to see IDs. It's good to have them, but maybe unnecessary, not unnecessary. So what attribute status can help with is I can say this requirement is still a draft. Let's read it again. Maybe we can, maybe we will change the type as a user requirement. User requirement. And we are showing some attributes. Yes. It's now user requirement. And as a driver, I want actually not bad word because it's a stakeholder, a driver. As a driver, so if you want to make the some text bold, you just double click here, and you have this text editing parameters. You just choose one and make it bold. I want the car to provide visual and audio alerts. When I exceed the legal speed limit based on real-time map data, I will remove this. Exceed the legal speed limit, because it's already the implementation and I want to work more on implementation. When I exceed the legal or the current legal speed limit, so that I can quickly reduce speed and avoid traffic violation accidents. I think the accidents is the most important thing. But we have two or maybe three items that we can identify in this user story: visual and audio alerts, current legal speed limit. So let's break down in system requirements. Typo. What's wrong with this word? Oh my god. Requirements. Put it like this. Requirements. Okay. Let's add here basic requirements. Okay, this one, let's put it approved. Okay, we have it. I want to have kind of chapter heading. You see, if I create heading under this one, it's making to one. I will put it back like promote. So I put here backlog or draft. And I will put all of this into this chapter. So I need to choose all of them with a shift. Or if you want, you can choose several. But I choose all of them and just drag them underneath. And I will demote them as well. So this, I don't need the status and the headings. System requirements. The system compares the car's current speed with legal limit. It's a good requirement. The drivers can configure custom alert. We'll discuss later. When the car exceeds the threshold, warning is issued with dashboard display. Okay. The alert stops once the vehicle speed is within the allowed limit. Okay. This is just the text. What needs to be done? Let's transform this into requirement. The system determines the legal speed limit using GPS and up-to-date map data. Drivers can configure custom alert. Okay, this is for later. I think this is not the speed assistance system. So the determination of the legal speed, maybe we'll discuss this later. Could be a different solution. But let's break down this. Okay, I will write this down like this. I'll use the ISA, like intelligent speed assistant system, should notify driver when the car exceeds the current legal speed limit. Using dashboard display and an audible tone. Let's ask ChatGPT with this. Please make 2 proposals to two proposals of requirement. Like this, please. I don't know why I'm writing please. I want to be polite to everyone. Convert following text into technical requirement using, let's say, in Cozy book of system engineering. No, not. Let's write IREP. IREP guidelines. Guidelines. Make two options and provide verification method. And I put this text. So why IREP? IREP is International Requirements Engineering Board. Let's see writing. Here's what we have. And this is the description. We have system shall use a warning to the driver whenever the vehicle current speed exceeds application legal speed using a dashboard visual display and audible tone. Great. Precondition vehicle's operation. Okay, this could be useful for us later. Verification method. It's a good thing to write requirement that you can think right away how to verify this requirement. And then, so all the requirements should be verifiable or testable, I don't know. Verifiable, yeah. And then you can judge if you wrote a nice requirement. So as I want to break down this further, I will use the option 1. I'll copy this here. And I'm copying with Control-Shift-V to basically to paste the easy text and plain text to be able to edit this here. So I see, okay, now it's updated. So the I say I'll remove this because I have description here. Okay, the ICA shall issue a warning to the driver whenever the vehicle current speed exceeds the applicable legal speed limit using dashboard visual display. So basically very similar to this, but this will be our main requirement, system requirement. And then we'll break down this into further requirements. And in the same way, we can start draw functional diagram. It's text wrong. Notify driver using put okay using dashboard visual display in audible tone. We have certain information here. maybe I'll put it here, but this one, our main function that I'll notify the driver. And this is where maybe we need to break it down further. We need to, what do we need for this is maybe a switch again to this compare car's current speed with the legal limit. This is where we change the flow. Oops, sorry. Some wrong thing I pasted, so let's paste again. Compare the car's current speed with the legal limit. And notify, okay. Okay, and I will write the, let's write the system. Let's write here the system shall compare the car's current speed with legal limit. That's right. Let me think further. Notify driver. I think this can be broken down into 2 items. So I'll put this up. So display visual warning. And at some point of time, play audio warning. So we can remove this text. Let me do the following. I will combine like this. We'll break it down further. Just right now, I want to group a section. Yeah, so we will notify the driver using visual warning, displaying visual warning and playing audio warning. And we need to put something in between here. So compare the car speed with the legal limit. So this will be kind of cyclic thing. Maybe we will need to write it down or break it down later, like how often we system executes this and what I want to do in between. And this is like we need to put here a different form, like decision, right? If um, if current speed exceed a legal limit, then it's kind of a question, right? So to have a decision making, and yes, we notify the driver, and if no, we continue compare. No. So let's keep it right now like this and go back to requirements. We have this requirement as well. So I will do the refresh. The system shall compare the car's current speed with a legal limit. To drive whenever the vehicle current speed exceeds applicable legal speed using dashboard, visual display, and audible tone. The system shall compare the car. It's great. Let's put it here. The system shall stop warning once the vehicle speed is within the allowed limit. So notifying the driver and then we still like, because this is cyclic, right? We need to still, even when notifying the driver, we still need to compare speed limit to the current. And we need to add here if the speed if the speed is lower, then we need to stop notification. So I will do like this. Stop notification, or like, let's say, stop warning. And then continue comparing. Right. Then I think I will remove this and put here now. And now we can provide kind of parameters for the first, let's say, for the first requirement, the main requirement. I'll put this like this. Like this, if the, and I think we need to write parameters. Let's call it, let me think, what would we have here? If the current speed is bigger than legal speed by 3, I will put like kilometer per hour. System shall notify driver. So I will change here to, let's say, by this requirement by 1 kilometer per hour for, let's say, period of time 2 seconds. I will put like this. We kind of have right now first parameters. And I think we can update the first requirement. Let me wait for this one to be saved, maybe. Okay, like this. And we can move this requirement. The system shall compare the car's current speed with the legal limit. Let's rename this parameter to legal limit and legal speed limit. Okay, this requirement being saved, so we can so we have here we have a notify driver function. We have compare cars speed. And stopping the warning. So we have, let's say, let's call them like 3 first functions. Notify the driver. We can write here system shall display visual warning. Warning. And system shall play audio warning. So let's do small structure here. So we have 3 functions. Maybe the flow is not correct, but we have those 3 functions. And 3 functions in combination gives us fulfilling the user story. And I want to start with the comparing function. We'll call it compare like analyze vehicle speed. And compares the car's current speed with the legal speed is the actually it will be kind of some function, right? So it will be analyze vehicle speed and then compares. So then we kind of can have kind of decision making here, right? Yes, identifying. If no, kind of stop warning. Let's keep it like this for now. See this current Speed exceed legal limit by, how much was that? 1 kilometer per hour for 2 seconds. If yes, notify the driver. If not, stop warning. And kind of coming back, the other stuff, like, let's say, to remove the warning after some time, we will discuss later, but for now, let's keep it like this. Okay, here's the and okay, so good. We have 3 functions. We put right now the structure. So I will insert after, and I will put analyze vehicle speed. And then we have notify driver, put here, notify driver. Maybe we'll rename later because there's many notification for the driver, like over speeding. And we will have stop warning or stop notification. Just better word, notification. Like this, stop notification. And again, over speeding. So maybe in Excel it will be better. Just by now using the doors to have everything in the system, and you can see what is happening. So right now I'm choosing these requirements and I make them as heading, and we will demote the whole chapter, and then we'll have system requirements, or we'll rename later what this actually is. So, and then we work on each function independently or parameterize it. So the system shall compare the car's current speed with the legal limit. So if the current speed higher than legal speed limit by 1 kilometer for 2 seconds, the system shall notify the driver. And we have 2 different warnings. System shall display visual warning, audio warning. System shall stop warning once the vehicle speed is within allowed limit. We can expand this, and another system, the system or system, okay, that's right. Just system without system shall stop warning after shall stop audio warning. It's annoying. After 5 seconds. But keep visual warning. So it's kind of also maybe some functions of audio warning, visual warning. And now it's an interesting question that we can think about. So analyze vehicle speed is certainly the function, but notifying the driver and stop notifying the driver could be also system state, right? The system is constantly analyzing the speed, so we can shall compare car's current speed with the legal limit every 400 milliseconds. Display visual warning. We can break down this and we can bring down this. So we can write down, we can let me think a little bit. Let's say one requirement that I think let me think a little bit more. Let's use the so I think I need to take a break a little bit to think further. All right, some information I'd like to add here is to specify the notifications. So system shall display visual warning using vehicle dashboard. In this modern vehicle kind of have multiple dashboards. We can put here main dashboard, And system shall play audio warning using vehicle sound system. All right, for now, I will do it like this. And note. And we will play around with the graphical representation. So right now we have this function, analyze vehicle speed, and we need to put it like a normal function diagram. So notified driver is as input should be a signal, or a signal. To start notification, we need to kind of a trigger, and we need to name it somehow. I think I will put here just another arrow, and we will have an output is actually display visual warning and play. It's not a function, but actual outputs, visual warning, audio warning. I need to think about this because play audio warning is kind of functions of another split, what we just saw. We need to put here the components. We just written the requirements that we need to have main dashboard, and we'll need to have a sound system. And main dashboard could be also kind of a system. So we are like doing some kind of logical diagram right now. So we have main dashboard, sound system, and because this display visual warning and play audio warning, it's kind of functions of these components. So I'll keep it right now here, but we'll see. So every function has an input and output. And here we need to trigger kind of overspeeding. It's called overspeeding. It's kind of a state, a vehicle state. And and it could be a signal from certain ECU that let me change here the thing so we know this is logical. We also have vehicle control units, some ECU where the software driving, so we will have as well this software. I'll call it just SV. Maybe I'll keep VCUs like a normal thing with that runs the software on it. So I'll put here overspeeding. If no, it's normal speed. And there wouldn't be any overspeeding or so. So if we have overspeeding, we start notification of the driver, and as the outputs, we trigger. It will be then 2 outputs. I'll write as a text here. Just, display over speeding, and another one will be play. It just maybe it's wrong names, but it will be a triggers. So if we have overspeeding, we display visual warning. Let's do like this. And the arrow put here like this, and put this like this, and so if you have an idea and have proposals, I highly welcome them. So it's still notify the driver, so it's basically coming to overspeeding state, and we requesting to do this stuff. Display visual warning, play audio warning, and if we have normal speed, we do stop notifications, and maybe put these parameters here like display overspeeding, and here as the display we'll have display visual warning as an output of this. Because this is a signal, and we will have blinking speed limit as an output. Oops. That's an output, and here, here, it will be for the audio, play sound number. Number 1. Okay. Maybe it's not number 1, but we need to write something. And we have, if we have stop notification, if we need to stop notification. We just need to if we have a normal speed, we have to stop notification, so it means we will output it as something similar like this. Play overspeeding and maybe stop overspeeding. Overspeeding, play overspeeding. So because I'll explain right now what are my thoughts. So these functions, these two are done by vehicle control unit, and these functions done by main dashboard, right? So it's another ECU, different, another ECU or another part of the same ECU. I don't know. We don't think about this right now, and that's why we need to, from one ECU, set signal to another ECU. So I'll put it like this. We have kind of connections. So I don't know if I'm overcomplicating this, but here, blinking speed limit, display, main dashboard displaying speed limit, playing the sound, and we stop. We like doing stop. Let's do stop. And here display was speeding. Show. I don't know. Parameters. Play over speeding. Play or yes. display overspeeding. Stop. So we'll put here as a yes. So let's say we have parameters coming from vehicle control unit to the main dashboard. It's called display overspeeding. And while we're stopping, it should stop and display visual warning. And then here, blinking speed limit, normal speed limit. So we have to stay within our system. Our system is not let's say, a system of the dashboard, or it's not sound system. So we kind of stopping here. This is what we say, keep as an output to another system or to another component. And what the component is doing with these parameters, we basically try to not care, or kind of this is the estimation, right? What could be, or like maybe this will be our boundary. I think, yeah, we need to think about this, how we implement the warnings, because yeah, we are the warning system. So right now we have blinking speed limit, we have playing the sound, and if we stop notifications, we have here normal speed limit, show, yeah, blinking speed, no, normal speed limit. And then like stop playing sound. Here no show display stop playing sound. Here we have play audio, play sound 1, and we have here as well following thing. I'll queue for 5 seconds. Right, and sound 1, which is for 5 seconds. All right. So we notified if the speed is okay, we stop notification. Audio notification is limited. And we have identified sound system, main dashboard, vehicle control unit, and we can expand this. So the system shall compare the currents. The system shall notify the driver, and then I will rename this. If this happens, I would write like this: VCU should send and this. All right, so if the current speed bigger than the legal speed, 1 kilometer for 2 seconds, VCU should send display overspeeding yes and play overspeeding yes. So if you want to delete, just remove. So this is parameters. Should okay, let's keep it like this. The system shall display visual warning using vehicle main dashboard. The system shall play audio. This we can think we can put it here. Just a second, I'll just keep it like this. And so this analysis happening on VCU, right? If the current speed, legal speed, so this one part is analysis, then we have overspeeding. Yes. Then we write this down as well. The current speed, then overspeeding is yes. If then we have another function which use overspeeding as an input. If overspeeding is yes, then VCU should send display overspeeding yes and play overspeeding yes. And then we have here if display overspeeding yes, then no. This for speeding yes, then VCU should send if display overspeeding yes, then main dashboard should display visual warning. Then main dashboard should display, we did call it blinking speed limit. If play over speeding yes, then sound system shall play sound number 1 for 5 seconds, and I think this we can remove because the time limit is here. Sound number 1, 5 seconds. I'm just creating the parameters. And here we have another requirement. If overspeeding, no. No normal speed. If overspeeding equals no, then we should send display overspeeding. Maybe it's no. Okay, it could be true or false, right? And I'm just using no, yes, no for now. Maybe we can update later. The system shall stop. Okay, and this basically means that if overspeeding is no, then we're sending display overspeeding no and play overspeeding no. Then we have requirements for the dashboard. If display overspeeding no, then main dashboard shall display normal, normal, speed limit, and if play overspeeding no, then sound system shall stop. Shall stop playing sound number 1. All right. We discussed notification and stopping notification, visual warning, audio warning, and how to stop those warnings. And we come up with some parameters. We come up with some components of our ISA system. we described certain system functionalities, which is good. And the next, what we're gonna do later is we will think. So we were thinking about the solution how to warn a driver and how to stop warn a driver. For now, we still have open, like in our backlog, the driver can configure this the speed alert. We have open about what are the inputs for analysis. Like I think we will do this in the next session. We will think about how do we know the current speed? How do we know the current legal limit? And we will think about the other systems that can support our system. So right now we kind of have already logical and physical. Physical diagram we don't have, we have a logical, we have 3 components of the logical diagram. And next time we will think about inputs towards our system. Thank you for sticking with me.